Hey folks, welcome back. This is Joel, and in this series, we are talking about Silver Peak's SD-WAN solution. Now, we've done a bunch of things in this series already, right? We had an overview session, then we kind of talked about how to bring up the Edgeconnect appliances. We did a bit of configuration on the orchestrator. We also explored things like deployment profiles. We did a bit of zero-touch provisioning and so on, right? Now in this video, what we'll do is we'll target redundancy, right, or high availability, right, and we'll try to kind of bring this concept into the Silver Peaks solution, right. So let's kind of get onto my screen here. So this is my topology, right. Like you see, we have like about 5 appliances here, SP1 to SP5. All of them are up and running. We'll be targeting only this particular we'll be just targeting Paris site for this particular video, right. And what we're trying to do now is we'll start with so we've got a couple of appliances, right. What you observe here is SP2 has access to only one transport, which is MPLS, whereas SP3 has access to internet and 4G, right. So what we are really trying to do here is, can I, because this guy has access to only one transport, can I somehow share this particular transport with this guy? Can I share this 4G also with this guy, right? That's what we are trying to do. Similarly, I mean, MPLS is here, so can I share this MPLS transport with the other, with the SP3? So right, so logically what we are trying to do is, at the end of this exercise, SP3 will have access to its two physical transport, and also it will have access to MPLS, right, through this logical tunnel which we are trying to create. Similarly, SP2 will have access to its MPLS, and it will also have access to the rest of the two transports, right, which is 4G and internet, through a logical tunnel which we'll try to create here. That's really as simple as what we are trying to do, right? So that's going to take care of the redundancy on the WAN side. But what about the LAN side? So on the LAN side, we'll use simple VRRP, right? We'll use VRRP. We'll make one of them as the master or active and the other one as the standby or backup, right? And then we will make sure that we send the traffic from the client. It is going to hit the master, right, and then go out into the network. Either it can use this MPLS, or it can use the internet or 4G transports, right, through the logical tunnel. That's simple as such. So that's what we are trying to target. Okay. All right. So now that we know the game plan, what I'll do is, let me pull up my orchestrator here. All right. So that's my orchestrator, right? So let's start with where is my, so that's my orchestrator. Perfect. So where we are going to do this, we are going to do with the site, with the Paris site, correct? So let's just right click on SP2, right, and we'll open up deployment here. Okay, so there should be an option here to enable Edgeconnect HA, right? So you see there's an option here called Edgeconnect HA. So we're gonna click on it. It's gonna give you some things, that's fine. We're gonna close this. So we are enabled Edgeconnect HA. Okay. Now we need to select a peer, right? So this is, we have selected SP2. So here at the bottom, you have an option to select who is going to be a peer, because if you want to do an HA, you need two appliances, right? You selected SP2, so obviously the other guy is going to be SP3. Perfect. And once you do that, you can see here, it's going to ask you for the appliances, the WAN interfaces which you really want to use. Okay. So on the SP3 side, if you see, we are already using WAN 0 and WAN 1. So I'm going to use here WAN 2. Okay. Because we're already using the WAN. So technically, I think you can do the HA using either your WAN interfaces, or you can also do using the LAN interfaces. You can't use the management interface for this approach, right? Whereas on the top, I think I'm good to kind of use WAN 1, right? Because we'll use WAN 1 on EC2, because we are just using WAN 0 here. So we are good to use WAN 1. Whereas on the SP3 side, we have an empty interface on the WAN 2, so we'll use WAN 2. Perfect. All right. So now that you see these two appliances are working together, we should also probably recalculate our licenses and bandwidth. So I'm going to hit the calculate button, and you see automatically, because the total number of now these two devices will work as if they are like a single device, right, a single logical entity, because they are in HA. So because I hit the calculate, you can see the traffic, the total bandwidth has increased, for this whole cluster of sort from 2 to 6, right? Because 2 plus 2 plus 2, it's gone to 6 over here. Perfect. right? And also, if you technically look at this, right, what has happened is, let me use my pen here, because we've created a logical entity of sort, right? Each of the plans now has, and that's what we really discussed, right? What we're trying to do, we are uplink with uplink sharing. What we're trying to do is, we basically have each of the plans has access to the tree transports, right? Which is, ultimately going to be which one? Your MPLS, your internet, and your LTE, right, or 4G, right? So you have each of the plans, right, which is this is going to be this is SP2 and this is going to be SP3, right? So each of these guys have access to this, right? So naturally you can understand why the bandwidth, right? You would need each of the plans to be able to handle 2 plus 2 plus 2, that is 6 Mbps. In our case we are using 2, right? So that makes it, that also means that we'll have to change the boost, right? I mean, doesn't necessarily, you don't really have to change it, but if you're designing it the right way, you would need to obviously recalculate your boost. In my case, like we have done in the previous videos, I'm not really caring about the exact boost value, because I really have I'm using like a demo license of sorts, so I have a good set of limit, right? I don't really have a higher threshold. This is just a home lab, so I'm good to kind of go and increase both of these guys to 6. I'm not able to increase this to 6. Let me hit calculate once again. Interesting, I'm not able to hit this to 6, but that's maybe I'll have to do it from SP3 later, but that's okay. So for now this is good, so I was able to increase this to 6, right? Okay, so we've got rest everything covered. So it's as simple as that, right? All you have to do was the two devices, right? In our topology, as you saw, you can see that they're both connected by so SP2 is on E2 and SP3 is the E2 interfaces, right? So this is remember when we brought these two appliances up in the previous videos, we have correctly marked them with the right WAN interfaces, right? So on SP2, this particular interface has been tagged with let me just write it down for your reference. This is actually WAN 1 and this is your WAN 2. So they have been tagged, right? The labels have been put in correctly. That's why we were able to select those two interfaces. You need to use obviously those two interfaces which are connecting each other, right? Otherwise you'll not be able to create that HA, right? So we are good with this. I still need to verify this boost value. I will probably do that, but before that let me just hit the save here, right? So that's going well, and you can see what's happened here. You can see there is a HA kind of a symbol which is starting to show up here, right? Which means that our configurations has gone in, and as soon as that happened, you can see we are starting to see some alarms. The reason is very acceptable, because you see here on the top, orchestration is doing some job, right? Which is, it is trying to recalculate all the IPsec tunnels and configure all of that, everything related to the overlay, right? It's trying to create all of that, so it takes a little bit of time for that to happen, but that's fine. What we'll try to do is, I still want to fix that boost, remember, so I will just try to do it from SP3. So I'll just go to SP3, right click, go to deployment. Let's see if it allows me to change the boost value from 4000 to 6000, right? So when I opened SP3 shows on the top, SP2 shows below now, right? And now, okay, there you go. Now I can change the config here. So that's a good learning. So if you really want to change the boost for that appliance, you need to right click it and open it, right? Otherwise, so you see, because I opened SP2, it is not allowing me to edit because I opened SP3, it's not allowing me to edit SP2, which is fine. Okay. So that's good. That's all settled. So rest everything is fine as it is. I'm going to hit the save button. Okay, next thing we really have to do is, we again haven't talked a lot about the orchestration piece. When I say orchestration, we did not speak a lot about how the IPsec tunnels are going to be formed between the edge appliances and so on. And technically, you don't even really need to know, right? You'll probably not even find a lot of information of that online as well, because Silver Peak Orchestrator kind of does it behind your back, right? You just need to know that it is going to create those full mesh IPsec tunnels between each of the appliances. but how does it create and what is the exact workflow, all of that, right? You don't really need to know, right? But that being said, one important piece you need to understand is if you don't want IPsec tunnels to be created between two appliances, right? You will have to give the same site name, right? You have to give the same site name. This is not the site name. What we created here are groups, right? But site name you'll have to give the same for both the appliances. Now in this case, you see, I know that these two are appliances which are acting in active standby, right? And they're present in the same location, probably in the same, you know, IT room of sort, right? So I don't really need IPsec tunnels between these two appliances, right? No point in that. So what I'll do is I will I can click on right click, right, and I can go to system information. I think I've opened on SP2. Okay, so on SP2 there should be an option called system settings, and here you see there should be site name, right? So we can change the site name. So this one is supposed to be what, Paris, right? So I'm gonna just put Paris here for the site name, and then gonna hit the save button. Right, let me just check if it has gone through. Site information. Oh, it's not gone in. Okay, let me try to put it again and then hit the save button. I've seen this issue sometimes, you know, it doesn't really take in, so just gotta make sure that it goes through. So there you go, successfully changed settings. Let me double check again. Site information and system, yeah, now it's gone in. Perfect. Let's do the same thing on SP3 as well. So system information. So we are trying to keep the same site name for both the appliances so that, you know, they don't form tunnels between them, right? So I'm going to change this to you know, the Paris. It's got to be same. Perfect. So looks like the settings has gone in. Okay, so that's good. Now the last part which we also want to do here is we have done the HA configuration on the WAN side, but remember we also talked about the VRRP, right? On the LAN side we want to create VRRP, so let's do that. Okay, so for that we'll just select both the appliances. Here we'll go to configuration, right, and there should be something called networking and VRRP. Okay, so because I've selected the two appliances, SP2 and SP3 is showing up here, which is fine. Okay, so we are going to go to SP2 first. Just click on this pencil icon. Okay, we'll add VRRP, right? We can put a group ID if you want, so we'll put group ID as 1. This VRRP is on the LAN side, admin state is up. We'll need a virtual IP, right? So let's use 10.99. What is going to be the virtual IP? If you my topology here, it's 10.99.20, right? So I'm going to use something like 20.100. So that's what I'm going to use as my VRRP, right? Let's use a priority value. So this is on SP2, so I'm going to use something like 254 as the priority. Preemption is enabled. I'm going to hit the save button. Let's do something similar on SP3 as well. Let's click on the pencil icon and put in the same let's put the we'll have to put the same VRRP IP, right, the virtual IP. Once it loads, there you go. So I'm gonna say add VRRP, group ID is 1, the virtual IP is going to be 10.99.20.100, right? Perfect. And let's go with we'll keep the priority as default, and preemption we are going to disable it, right? We don't really want, we want SP2 to be primary, so that's why we are just going to keep we want always SP3 to be the standby or the secondary. So this should be fine. We're going to hit the save button here. Okay, so that's good, right? So just make sure you can see 10.99.20.100 right over here, and you can see I think the master is already has been picked up, which is 10.99.20.101, right? This is all happening on the LAN side, which is via this interface over here, correct? The Ethernet 3 interface over here, Ethernet 3 interface over here. Give me a second, let me just go check if these interfaces are configured correctly. One sec. Perfect. So looks good. I just checked if the configuration was right. On the switch side, I just wanted to check if the ports have been put in the trunk mode and they have been put. So configuration is right on the switch side. Let's look at again, if you look at this one, right, you can clearly see that VRRP has converged. SP2 has been picked as a master. This guy is the backup. This is the virtual IP, and you can see the master is basically, because SP2, this is the IP address, right? 10.99.20.101, right? If you want to double confirm, what you can do is you can just go to maybe one of this guy, go to deployment, and this 101 IP should be actually on the SP2, right? Let's double confirm that. Okay, so you can see, yeah, we could probably, is this one? Yeah, so this is 101, right, which is good. Perfect. All right, so now let's try to look at the, I mean, we have set up the HA, but let's try to kind of look at those tunnels, right, or the logical tunnels which we spoke of, right? What I mean by logical tunnels, this one, right, the along this interface, we have those logical tunnels which we spoke of, because of which these two guys are able to share those WAN uplinks, right? So where do we check that? Let's go back to orchestrator, right, and let's go to configuration, networking, and have we already selected? Okay, so we have selected this one, right? Let's go to configuration, networking and deployment. Right, so this is good. So here you see there is an option called, by the way, you can see all the details over here. Each of the plans seems to have access to all the 3 WANs now, which is good. Let's click on details here. Perfect, and let's kind of filter it with the HA. Let's just drag this a little bit to the right or to the left, my bad. I think the table is a bit small. Okay, that's fine. So you see there is a column here on the right side which says, let me get rid of this. So there is a column here which says, let me hover over here. Is this interface auto configured for Edgeconnect high availability, right? So if I just sort it here, you can see it says yes for the first 6 interfaces. Okay, and let's make sense of this, right? If you look at the, if you try to kind of look at, where's my pen? So let's try to understand. So you see SP2 ideally has access to, SP2 had access to only MPLS, correct? Where is the MPLS? So you can see this is the physical SP2's MPLS interface, because it is on WAN 0. Whereas SP3, if you look at SP3, it has access to WAN 0, WAN 1, which is INET and LTE. So these are the physical interfaces, whatever I've shown here, right? Let me kind of erase, sorry. Let me grab my pen and just get rid of this. Okay, so the whatever I've highlighted in blue are the physical interfaces. But now because of this, sharing business, what we have done, right? Let me use a different color. You can see SP2 has access to internet. SP2 has access to LTE, whereas SP3 has access to MPLS. And how it is doing, you can see it is doing using VLAN. So you can see VLAN 100 and 101 is used for it's basically using, it's doing something like sub interface, right? That interface, it is kind of dividing it into multiple segments. So on VLAN 100, right, it is able to kind of share this, SP2 is able to get access of INET and LTE, whereas on VLAN, so 100, 101, on VLAN 102, you can see SP3 is able to get a hold of MPLS from the other side, right? And the other 3 tunnels are basically nothing but, so it's basically tunnel originating and terminating, right? So the other 3 are basically the same thing, right? So it's just a 2 bidirectional endpoints which they have listed down here. You can actually look at the IP addresses to understand that, right? So when you create they are basically creating a point-to-point segment. So because you're creating a point to point, let me just get rid of this again. Right, so you can see if you look at the IP addresses here, the logical tunnels which I'm talking about, those are like point to point segments, right? So you can see the IP address is 169, and these are not routable IP address, right? This is just for the point to point tunnels. You can't route using these IP addresses. Just think of it as private IPs only for those point to point tunnels. So you can see using a /30, right, which means you can get 4 addresses out of this, right? So 1.1 is here, whereas the other end of the tunnel will be over here, right? The one which doesn't have anything mentioned here, but it's actually the other point of the same tunnel. Similarly, 1.5 and 1.6, and we have 1.9 and 1.10, right? So you understand, it's able to create those point-to-point tunnels, and it's able to kind of share the uplinks with the other uplinks. So that's one way for you to verify. All you have to do is go to this column and just search for the HA, wherever it says yes, right? Those are the interfaces which are automatically created for you by the uplines. Perfect. All right, so we can get rid of this. There are other ways to kind of look at similar data as well, right? So we can also go to configuration, networking, and interfaces, right? And if you go down here and probably go to, again, maybe dynamic, and you can see the interfaces which were created dynamically, right, also show up here, right? So you can see the 100, 101, 102, they are kind of showing up here. Perfect. Now, I mean, ultimately the whole point of doing this sharing business is so that we can create more IPsec tunnels, right? Which means, let's take one example, right? Initially, if I had, say I was over here, I was on SP2, and we had access to only one MPLS, correct? We had access to MPLS. So from here, let's take one more appliance, right? Like this guy, right? The only tunnel which we would have had is this tunnel, right? Via the MPLS network. Now that we have actually, let's use a different color. Now that we have kind of added this 4G and internet to this guy, right? What we can do is technically now we can create tunnels over internet, as well as we can create the tunnels over what? Over 4G as well, correct? So we should be actually able to see these tunnels, correct? And there should also be a resemblance to that 169 IP address which we just now saw. Right, so let's check if this really checks out. Right, for that, what we can do is we could go back here. I think in the monitoring you'll probably find configuration, networking, and I think it should be over here, tunnels, right? So here you can see, so we've got, so I mean this literally shows all the tunnels. Since we have highlighted only Paris site, it is just showing the tunnels which are either originating from SP to SP3 or terminating on SP to SP3, right? So here you can see, if I probably, let's see if I can filter here. If I sort based on this 169, right, you can see these are all the tunnels which the appliances are creating. Let me use my pen again. So these all tunnels, right, you can clearly see these are all coming because of the uplink sharing, right? So you can see SP2 and SP3 here. So you can see SP2, SP3 here is kind of able to use this, right, to create tunnels with the remote, these are the remote, when I say remote, I mean these are the remote IP addresses of the tunnel destinations, right, with the other end, with the other appliances. So EC1, EC4, EC5, so it's able to create IPsec tunnels with those endpoints, but using this one, using this new superpower which they have got, right, which is access to the tunnels through the peer, right? It is also obviously able to create tunnels through the physical interfaces which it had, like for example SP2 already had access to MPLS, right? So you can see it is able to create those as well. You can see the MPLS tunnels here. So these are through the physical, but through its physically connected MPLS. But here you can see SP2 it is also able to create the same tunnels using using those logical tunnels which we or basically through uplink sharing, right? So just wanted to kind of show you that as well. Okay, let's just get rid of that. Okay. The other thing is, while we are here, probably we can click on pass through. Pass through, like we have discussed in the previous video, whenever you see the word pass through in context of Silver Peak, always remember that it is basically concerning the traffic which will not use the IPsec tunnels, right? It's basically pass through basically means the traffic which is exiting directly local breakout, right? That's the meaning of pass through. So if there is some traffic which say from SP2, right, we want to send say some traffic from SP2 to the internet, which is over here, right? We don't really need to send it over a tunnel, correct? We can directly say this guy wants to reach this internet host, right? All you can do is you can come here, and from here directly exit out. In this case, I mean, ideally this is MPLS, so I think our breakout policy, I think as per our current BIOS, right, I think it will probably prefer the internet transport, so it is going to go like this and then go like this. So you basically, the point is you use pass through when you want to do local breakout, right? So when you're doing local breakout, there is no concept of what IPsec, right? There is no, you're not using IPsec tunnels, you're directly breaking out. Think of it as in Cisco we did something called as DIA, right? Direct internet access. So very similar to that. That's what local breakout is. Remember that whenever you see the word pass through, it means that you're not using those IPsec tunnels, the overlay tunnels, to send your traffic. You're just directly dropping the traffic on the physical interface, the underlay interface, and through that it exits the box, right? So that's important to understand as well. So now that, because you have created all these logical tunnels here, what I mean by logical is you have given SP2 the access to what 4G as well as internet, correct? So which means that you have actually technically created two pass-throughs here, right? So you have given this case, so you have created pass-through interfaces as well, right? I think these guys still call this pass-through interface as a tunnel, but don't get confused. They actually don't mean it to be a tunnel. It's just an interface, right? So if you go to pass through, it shows it under tunnels here, right? So let me just get rid of that. So you see it shows it under tunnels, but it's actually not a tunnel, right? Here also it keeps on telling it's a tunnel, but technically it is not a tunnel. It's just what they call it, because you see here in the remote IP there is no IP address. It's all blank, right? So you can filter it here. You can see these are the pass-through interfaces, and you see pass-through also it creates per bio. You can see we have talked about business intent overlays, right? So you can see for MPLS, it's creating a pass through. It's creating different pass throughs per bio as well, correct? Right. So if you again double click here and kind of analyze this, let's just look at one of them, right? So you can see real time. You can see real time, you can see real time, but this is all associated. This is internet, this is LTE, and this is MPLS, right? So for each of the business intent overlay, it is able to use, right, one of the transport of this sort, MPLS, LTE, and INET. So it is able to create that, so that based on your policy later, right, if you have a policy which says for pass-through traffic I want to use internet, then this particular pass-through will be used, and this will be the local IP which will be used for sending it onwards. If you decide that you want to use LTE for your real time, right, so this one will be used. But technically if you look at it, right, ultimately all of these IPs are same, right, because if you're using LTE for any of these overlay, it will end up using the same local IP, but they like to clearly segment it out and explicitly call out that this is the this is the interface which I'm going to use to send the traffic if it's a local breakout, right? So yeah, that's also very clearly nicely done. The only thing which I have a problem here is with probably the naming convention. We shouldn't call this a tunnel, because clearly you can see here you have local IP and you don't have anything in the remote IP, right? So it doesn't become a tunnel, but I think they've just gone with the convention of tunnels, because otherwise you probably can't display it under this tab. So I think we'll have to make a piece with it. Okay. Maybe one last thing we'll do is, let me just get rid of this, right? So remember we have, so here, right, again in Viptela, remember we had the concept of OMP routing, right? In I think SD branch we called it as OAP, right? Here these people like to call it as subnet sharing, right? So this is the, think of it as the overlay protocol, the overlay control plane, right? Control protocol, which is used for exchanging the routes, right? What I mean by that is, say this particular subnet, right? So this subnet has to be learned, right? So over the IPsec tunnels, right? It has to somehow come into here, right? So that, you know, this guy learns about this particular subnet, correct? It's not just there, but it also needs to be also learned on the other side, right? So only then you can have connectivity, right? So the protocol in the control plane which is used to kind of make this learning possible is subnet sharing. It's also bidirectional, right? Which means, you know, even these subnets need to be learned here, this subnet needs to be learned here and here. So, you know, whenever you hear the term subnet sharing, just think of it as the control plane which is used for kind of learning those overlay routes, right? Now that we have VRRP here, right, and remember we made this guy as the active and this guy as the standby, right? What we'll also try to do is we will basically make sure that the routes, right, which are basically, so remember we have kind of made this active standby, which means we have been able to send the traffic in this way, right? We have prioritized this guy over here, but when this guy is sending the traffic, right, he's going to, because there are two ways to get inside Paris, right? So he might send the traffic either here or he might send the traffic here, but that's not going to really work for us, right? If it's, it will technically work if the traffic comes on this guy, then we'll have to use the LAN interface to kind of, you know, we'll have to go like this, we'll have to come here and then we'll have to come. So you'll have to do some hairpinning, right? Which is not very optimal traffic flow. So what we can do instead of that is, when this subnet is sent to the outside world, how about when we are sending it from here, we'll send it with a better metric, right? So we'll send it say with a metric of 50, whereas when you're sending it from here, right, from this direction, we'll send it with a metric of 60, right? So when you increase the metric here, what will happen is, when say SP4 learns about this particular subnet, it is going to learn it from SP2 and SP3, right? But from SP2 it is going to learn with a metric of 50, whereas SP3 it is going to learn with a metric of 60. So it will always prefer this. So the traffic which is going to come into Paris, it will always use the tunnel towards SP2, and that will kind of prevent us from having asymmetric routing, right? Traffic is exiting from the subplans, coming inside through the subplans, right? So that's something which we want to do, and to do that we just need to increase, or we need to basically increase the metric on SP3. So let's do that. Let me get rid of that. Okay, so for that we'll go to the orchestrator. Let's just highlight SP3, right, and go to configuration, networking, and there should be, okay, under routing there is something called routes, right? So for the routes, let's wait for this, right? So there is a pencil icon here, you see around across the SP3s. I'm going to click on that pencil icon, and you can see here metric for automatically added routes is 50 now. That's a default value, so I'm going to change that to 60. For SP2, let's keep it as constant, right? So I'm going to save this one. Okay, makes sense. Just to verify, what we can do is we can go to SP1, right, and let's see if we can see the routes here, right? So on SP1 you can see, can we see the 10.99.20 route? There you go. So we can see the route. So you can see the 20 route is here and here, but from SP2 it is getting learned with the metric of 50. From SP3 it is getting learned with the metric of 60, right? So that's what we really wanted to do. Now the traffic will only be sent to SP2, right? It will prefer SP2. If the SP2 is not available, maybe that route is not available, then we will always be falling back on SP3. But by doing this, we are avoiding that whole asymmetric scenario. All right, so kind of to test this out, what we can do is we'll just, I have like a couple of uplands Windows machines here. Let me get them up. All right, so we've got both the machines here, right? So the London is on the top and the Paris is at the bottom. Let me just quickly show you the IP address on London, which is ipconfig is 10.99.10.11, right? Whereas let's come to the other machine and let's try the same thing. if I do IP config, so you can see here it is 10.99.20.11. I don't know if this is visible. Can I just increase the size of this? Let me see. Maximize maybe. Okay, maybe not. But okay, let me see if I can increase the size. Give me a second. Okay, much better. So you can see the IP address on this guy is 1099.20.11, right? So what I'll do now is, let's try to trace route. First, let's try to ping, right? Is it reachable? So so we are trying to ping from Paris to London now, right? So ping 10.99.10.11, right? So is that the right IP? 10.99.10.11. Yes, the IP is right. It's timing out. Let me just quickly see why it's timing out. Give me a second. Okay, looks like one of them went through. Maybe it was our ping. Let's try once again. Okay, there you go, right? So ping is going through now. So now let's try to do trace route, right? So trace route and the same thing, 10.99.10.11. So what I intend to see now is, because our Edgeconnect appliance, which is that SP2 is the active, right? From a VRRP perspective. So when we see the results, we should ideally see what? We should ideally see that the traffic is going like this. So I think this particular interface right over here as .101. So ideally we should see 101 in the path, right? So let's check that. Let's check if it works like we expect it to. There you go. So it is actually using 101, correct? Let's actually wait for this trace route to complete. Perfect, looks good. So we can also do a failover now. Let's see if we shut down EC2, will the traffic go to EC3, right? So let's try that. So I think we can do that from, should be able to do that from interfaces, I think. Let's see if we can use that. So let's go to site 2 here, right? And which is the interface which we need to shut down. Okay, maybe we can't do it from here, so we'll have to probably do it from let's say, I think we'll have to do it from the appliance manager, right? So let's do that. So let's go to SP2 appliance manager. All right, so we are on appliance manager. We should be able to go to configuration system, and here do we have yeah, we have interfaces. So here we have the hardware interfaces, right? So you see LAN 0, we can turn it down, right? It's going down. I think we'll hit the apply button here. So we are shutting down the LAN 0 for now, so that we can, so you can see the .101 interface has been shut down. It'll take some seconds for that to happen. And there you go, the interface is shut down, right? And because the main interface went down, even the sub interface which we had created earlier also has gone down, which is fine. Okay, now let's come back to our appliance, and let's run the same trace route. So this time, right, ideally if VRRP has reconverged, this should change from 20.101 to 20.102. And there you go, we have proved it, right? So you see it's changed to 20.102. So yeah, that's predominantly everything which I wanted to cover in this video, right? Probably quickly, if you want to quickly see here, you can see it's still using the same second hop, and then it will load onto the actual PC. So for the sake of completeness, let's also configure the Berlin site, right? If you look at the diagram here, so this is the Berlin site, and here we will not be using Edgeconnect HA like we did in Paris, right? Because here you see we had one appliance with only one transport, whereas we had the other appliance with 2 transports, right? Whereas here, if you look at SP4, it has access to both the transports, which is MPLS and internet. Same thing with the SP5 as well. It also has access to both the transport. So in this case, we don't really need to do the whole drama of uplink, sharing the uplinks and all of that, right? So we are good to kind of we have already configured the WAN links, so you have high availability, right? So even if one of the link goes down, even if this link goes down, you'll still have one more link to take over the traffic. What we'll basically configure is we will try to mainly configure the VRRP here, right? Because we want to make one of this box say SP4 as the master, so that all the traffic will be from the LAN side. We'll have redundancy. One of the box becomes the master, other one becomes the backup, we have redundancy on the LAN side. All right, so let's get started. Okay, the other important thing which we'll also have to do is because you have both of these boxes in the same site, we don't really want MPL. We don't really want IPsec tunnels between these guys, right? So how do you disable that? By using the same site name for both these boxes. So let's first do that change. All right, so let's go on to our orchestrator, and where do we do that? Let's go to, so the site which we are working is this guy. So let's do it one by one, right? So let's probably select SP3. Let's go to system information. And here, if you go to system settings, you have an option to put the site name, right? All we have to do is we have to put the same site. So this is Berlin. So I'm going to say site 3, maybe dash Berlin. Perfect. Let me just copy this, and we'll have to hit the save because we'll have to put the same thing on the other site as well. On the other device. Let's see if it really went in. Sometimes it doesn't. So let me just check once again. System information. System said, oh, it's not gone in. So sometimes that happens. So let's try to hit the save. Okay, just to verify. That's not going in. Give me a second, let me try to fix it. Alright, it's finally gone in. Sometimes it takes 1 or 2 tries to actually save that config, right? So let's do the same thing on SP5 as well. Let's go to system settings. So I'm gonna change this to hit Berlin, and we're gonna hit the save button. Okay, so that's good, right? So let's just check once again. I think this is gonna take some time. Let me try it once again. All right, so I was able to fix that. Just took a couple of tries, that's it. But you see, I have the site name put in, right? And now once you did that, orchestrator will try to terminate any tunnels which were there between SP4 and SP5. You see, the orchestration was running, so that's why you see some alarms showing up. But you can see some of the tunnels are down is what they show, right? That's fine. It will take a little bit of time for things to settle down. Meanwhile, what we'll do is let's go and configure the VRRP part on the LAN side of SP4 and SP5. So where do we do the VRRP? I think we already have the VRRP tab open, but otherwise you would probably do it from configuration, networking, and VRRP, right? We can probably select our site which is of interest for us. All right, so we're working with, let's do SP4 first. Click on the pencil icon. We'll have to probably add, let's wait for a minute. Okay, there you go. We'll have to add VRRP here. We can add a group ID, right? The LAN 0 interface, state is up, all of that is fine. We'll have to put a virtual IP, right? So it's going to be 10.99.35.100, right? So that's going to be my virtual IP. Priority, I'm going to go with 254 because SP4 should be the master, right? So I'm going to enable preemption as well. Going to hit the save button. Let's go on to the second box, which is SP5. Let's get rid of that. So on the SP5 as well, we will add a VRRP plus, and we're gonna hit the group ID LAN 0. We'll have to put the virtual IP 10.99.35.100 again. Perfect. Priority, let it be preemption, we're gonna disable. We'll keep the priority as it is. Hit the save button, and that should take care of the VRRP part. The only last thing which is remaining is what? We also need to fix the overlay routing, right? Because otherwise we'll hit some very weird routing issues. So what I mean by that is, if you go back to my pen here, right? So you have SP4, we want this guy to be master and we want this guy to be backup, but both of them are connected to the LAN, right? So both of them are going to advertise this particular subnet to where? To the overlay, right? To the overlay. So if both of them are advertising with the same metric, right, then we might have issues where traffic is going out like this but coming back like this, right? And that might cause problems, especially if you're doing things like boost and TCP acceleration and all of that, right? You want the traffic to exit the same appliance and come back on the same appliance. So that's why active and standby is always what is recommended, right? So that being said, how do you fix this? What we'll do is we'll play around with metrics, right? The default metric of any route which is sent into the overlay, I think in the overlay, like I mentioned in the previous section, it is called subnet sharing, right? That's the overlay protocol of sort is what is used here. So what we'll do is when this particular subnet is sent by SP4, it is going to be sending with the metric of 50. What we'll do is when SP5 sends that same subnet, we'll send it with a metric of 60. Once you do that, what will happen is the overlay will start preferring only this route. The traffic will exit like this because of VRRP, but the traffic which is coming into Berlin also will prefer SP4 because of the smaller metric. That's what we are trying to achieve with this, right? So I'm gonna get rid of that. Let's get rid of that, and let's do the configuration. So all we gotta do is, so I think we already have routes here, right? But otherwise, if you don't have this tab open, all you have to do is go to configuration, networking, and routes, right? So this section we already have it. So I'm just gonna highlight SP5 because that's where we need to increase the metric, correct? So I'm gonna hit the pencil icon here, and you see metric for automatically added routes. We already have 55 technically. Yeah, I think we already have 55, so which should actually be good as well. I think we set that up when we did the pre-config, right? We did this, we brought up SP5 using zero trust provisioning. Remember, we had set it to 55, but otherwise default is 50. But that being said, just to kind of demonstrate, we'll just increase it instead to 60, right? And then gonna hit the save button. Okay, so the configuration is done. We can probably go to SP1, right? Let's click on, okay, so we clicked on SP1, and let's look at the routes what SP1 is learning, right? And we can also filter here with 10.99.35. So if you see here, what has happened is SP1 is learning about this route from SP4 using metric of 50, whereas it's learning from SP5 with metric of 60. That is what we wanted, right? So using this, we are basically preventing any kind of asymmetric routing, right? We are making sure that the traffic is exiting VRRP's primary, and the traffic is also entering back using the same path. Just to validate things, what we can do is, let me bring up this PC, right? We have a client here in this particular VLAN. So I'm going to bring that up so that we can do some ping test. Alright, so I've brought up this Windows machine, right, which is in my topology over here. So this guy, what we'll do is, let's look at its IP configuration, right? So let me first increase the size a little bit, one sec. Maybe that is better. Okay, so I'm gonna do IP config, and as you see, it is 10.99.35.11, and the default gateway has been set up to the VRRP IP, right? So what we'll do now is we'll try to ping ping maybe which one? We'll try to ping. So we are on Berlin. Let's try to ping this London machine, right? Let's try to do 10.30, sorry, 99 dot, I think it is 10.11. There you go, the ping is going through. And let's try to do trace route to the same IP, 10.99.10.11. Now ideally we should see the which hop we should see. We should see SP4. Why? Because if you see the VRRP configuration, right, VRRP state, you can see SP4 is the master and it is having an IP address of 1099.35.101. Correct? So that's the master IP, right? So we have made SP4 as the master of the VRRP. So we should ideally see .101 in our path. If SP5 becomes the master, it will actually get the IP of 35.102. Right here, it's not shown, but that will be the actual IP. Okay, so yeah, coming back, so you can see clearly that's the hop, right? The virtual IP is still .100, but the actual active device is the primary, right? So you can see clearly 10.99, 35.101 is going to be hit. Okay, so yeah, that's predominantly what I wanted to show you in this video. We kind of went about setting up Edgeconnect. Just to summarize, right, what we did here was we actually set up, use my pen. So in the Paris site, we did what we call as Edgeconnect HA, right? So we did Edgeconnect HA, where we kind of took this MPLS and we shared it with the other box, whereas we took these two and we shared it with this box, right? So as a result, each of these subplans had 3 uplinks, right? So kind of we ended up adding redundancy. And how did we do the sharing? Using logical tunnels, right? So you basically create logical tunnels here so that you can share your uplinks with your peer, right? And on the LAN side, we used VRRP. Okay, similar case with Berlin. With Berlin, what we did was on the LAN side we used VRRP. On the WAN side, we did not have to do anything because we already have redundancy here, right? Here we did this whole extra step because we did not have redundancy. In fact, SP2 just had one transport. If this was going down, then you would have lost connectivity from this box. So just to add more availability, we use this concept of Edgeconnect HA. Here it is not needed. Like I said, you already have redundancy. Each of the box already has 2 of the transports. So all we had to do was VRRP. And the other important thing which we also did was, to basically solve the problem, we did this on both the sides, but to explain what we did really was, once you make one of the box as the master for VRRP, right, this is standby, you want traffic to exit like this, right, which is great. But what about the traffic that is coming into the site, right? What if by mistake it comes like this? Not by mistake, I mean, if ideally both of them are presenting this particular subnet to the outside world. When I say outside world, on the overlay, right? Both of them are presenting the same subnet into the overlay. So there is a possibility that traffic can come directly to SP4 or it can come to SP5. How do you stop this? How do you stop the traffic coming like this? How do you stop this, and how do you make your traffic always come like this? That is, use the master, right? But for doing that, what we did was, when this particular route was advertised by both of these boxes, we changed the metric. We kept the metric here to be lower, we kept the metric here to be higher. So as a result, the overlay, right, when I say overlay, I mean any of these boxes wants to send traffic to the subnet, it will always prefer the SP4. Alright, so hope that was clear. So this all covers the high availability related designs on in any Silver Peaks topology, right? Yeah, that's about it for now. Thanks a lot for watching. Have a good one. Bye.